So last two classes we were discussing about measures of central tendency. Now we are going to discuss about the topic measures of dispersion. So now we are going to discuss about measures of dispersion. Okay. So with one example I will explain what is the use of this, why you want to study this, what is the need of this. Okay. So assume that there was a cricket match. Okay, cricket match. I have two players. Okay, player 1 and player 2. So total 5 matches was there. Total how many matches was there? 5 matches. These two are batters. Okay, they are batters. So they scored. Player 1 scored 48 in the first match, 50 in the second match, 52 in the third match, 49 in the fourth match, and 51. Okay. Player B scored 10, 30, 50, 70, 90. Okay. These were the scores scored by the batters, player 1 and player 2. Now the thing is that when I am finding the average, so if somebody is asking me how much scores, how much does player 1 scored. So if somebody is asking me like that, instead of saying all these values, I will be converting this into a single value. That is nothing but measure of central tendency, right? That is nothing but mean, right? So instead of saying all these values, I will be saying one value, nothing but on an average, player 1 scored how much scores? On an average, player 1 scored. So when I am calculating the mean of this, I will be getting 50. Okay, so I will be getting 50. So if somebody asks me how much score does a player 1 scored, if somebody is asking me like this, I can say that on an average he scored 50. Okay. Now when I am taking the average of player 2 is 10, 30, 50, 70, 90, right? And when I am taking the average of player 2 also, it's coming 50. See, player 1 is also having the average 50, player 2 is also having the average or mean 50, right? So when I am looking into the data, see, this guy scored almost near to 50, 51, that range, right? 48, 50, almost near to 50, right? See this guy scored 10, 30, 50, 70, 90, right? He is having very less as well as very low. So see, this guy is a consistent player, right? So we can rely on him, right? Why? Because anyway, if I am allowing him to bat, he might score till 50. Anyhow, he can score till 50. Why? Because his range is from 48 to 51, right? Anyway, in this range he will be scoring, so I can rely on him. The problem with this guy is, suppose I am playing a crucial match, he might score very less score also, he can score very high also, right? So I can't rely on him. What if he scored very less, right? But that is the thing, the only based on the measure of central tendency. This is a measure of central tendency, right? So only based on mean, we can't say that which player is better. So for that, we will be checking the consistency. For that consistency thing, what we need? Measures of dispersion. So I hope you understood this. So the thing is that when I am taking the simple understanding, when I am taking the average of this, it is 50. When I am taking the average of this value, it is also 50. But when I am looking into the values, this has very low value as well as high value. In this, all the values are almost near, right? Almost near to 50. So at that case, for understanding the spread of the data, so ultimate use of dispersion is to understand the spread of the data. Okay, so ultimate aim of measure of dispersion is to understand the spread of the data. So this data spreads, the spread of the data means what? This data has very low value as well as very high value, some moderate values also there, right? Here the spread of the data is very less. Why? Because all the values are near to 50. This has very low spread and this has very high spread. So for understanding this particular spread, we are using what? Measure of dispersion. And to understand, like if it is assumed that this is player 1 and player 2, to understand which player is more consistent, for that also we can use what? Dispersion. Okay, so understanding the consistency also we can use what? For understanding the consistency also we can use what? dispersion. Okay, so we'll move on to the definition of dispersion, measure of dispersion. Same thing only, this is actually the definition. So the definition of measure of central tendency is sorry, measure of the dispersion is, it is a statistical method, used to quantify the degree of variability or spread in a data set. So ultimately the aim of measure of dispersion is to understand the spread in the data set. Okay, so this is the definition for measure of dispersion. So in measure of dispersion we are studying mainly 4 things. In measure of central tendency we studied 3 things. One is mean, median and mode. Here we have 4 things. First one is range, second one is average deviation, third one is this thing you might have heard, variance, and fourth one is standard deviation. Okay, these 4 measures are the measures what we are studying in measure of dispersion. Okay, so we'll detailedly see what all are these measures. So first we'll discuss what you mean by saying range. Okay, this is a very simplest measure. So range is nothing but the simplest measures this is the simplest measure of dispersion. Why I will say so, with one example I will explain what is measures of dispersion, what is range. So we can take the same example of the player 1. So this was my data 48, 50, 52, 49, 51. Okay, so range is nothing but very simple. Range is equal to highest value minus lowest value. So in this particular data set, which is highest value 52, right, which is the lowest value 48, right? So it is nothing but 52 minus 48, which is equal to 4, right? So range is nothing but 4. Okay, range is nothing but 4. So very simple, right? To calculate the range, just subtract a higher value minus lower value, that's it. Okay, so we'll do one more problem based on this. This is very simple, I guess. So 10, 20, 13, 14, 15, 18, 28. Okay, so this was my data. So what is range? So if it is asked to write to find the range in the exam, you should write range is equal to highest value minus lowest value. Okay, highest value minus lowest value. So what is highest value in this? 28. What is the lowest value? 10, right? So minus 10. So 28 minus 10, which is equal to 18, right? So this is the range. So I hope this is very simple. You can do 2 problems based on this, or I will do one more problem. 1, 2, 3, 4, 5, 8, 0.5. Okay, so how can I find the range for this? Range is nothing but, so I will write HL, okay, HV, higher value minus lower value, HV minus LV. Okay, so 8 minus, so highest value is 8, right? Lowest value is 0.5, which is equal to 7.5, right? Simple. So you can do 2 problems based on this. 2, 4, 6, 9, 10, 1, 0, 8. 2, 2, 2, 2, 2, 2, 2. Okay. Then one more. You will do 3 problems. 1, 8, 9, 10, 0.5, 0.3, 0.2. Okay, do this many problems and submit. Okay, this is homework. Next topic we have is average deviation, right? Average deviation. So we will write the definition for the average deviation, then we'll explain what is average deviation. Okay, so average deviation is the average of so I'll write it down, average of absolute deviations of all observations and a central value. Okay, of all observations, here one and is there. Okay, and a central value. Okay, so there is one equation for this. That's nothing but average deviation. We denote this as AD. Okay, average deviation, which is equal to summation mod xi minus x bar divided by n. Okay, summation mod xi minus x bar divided by n. Don't get confused with this. I will explain this so you can easily understand this, what is the meaning of all these things. Okay, so we'll take one data set. Okay, 2, 4, 6, 8, 10. So actually what is the meaning of this average deviation is, so what is the first we will find what is the average of this. Average is nothing but mean, right? Mean is equal to 2 plus 4 is 6, 6 plus 6 is 8, 20 divided by 5, right? 2, 4, 5. Okay, there's nothing but 4. So we got the mean value as 4, right? So what this average deviation says is how much each value is deviated from this mean, how much each value is different from this mean. So first value, what is the difference, is nothing but subtraction. Okay, the meaning of difference or deviation is subtracting this from this. Okay, so what I will be doing, so I will be seeing how much each value is different from the mean. Okay, so first 2, right? So 4 minus 2, which is equal to 2. Again 4 minus 4, which is equal to 0. It is 2 units different from the mean. It is 0 unit different from the mean. Here it is again 2 unit different. 8 minus 4 unit difference is there. Next is 10 minus 4, which is equal to 6. So 6 unit difference are there. Okay, so the first term 2 unit difference is there. Here no difference because mean and the same, this is same value. Here 2 unit difference is there. Here how many? 4 unit difference is there. Here 6 unit difference is there. So ultimately average deviation, what I am doing is I will be seeing what is the deviation of each value from the mean, that is in these values, and I will be taking the average of that. So what I will be doing, I will be seeing what is the deviation of each observation from the mean, that is this values, and I will be taking the average of that. Average of that means I will be adding 2 plus 0 plus 2 plus 4 plus 6 divided by how many values are there? 1, 2, 3, 4, 5. Okay, this is the thing what I am actually doing. Okay, so this based on this equation I will explain what I am doing. So I'll go to the next page. So this was my question. Okay, this was my question. I got mean is equal to 20 by 5, which is equal to 4. Done. So my equation was summation xi minus x bar. X bar is nothing but what? Mean, right? Divided by n. That is nothing but AD. AD is nothing but average deviation. I have drawn 2 lines in this, right? 2 lines. So the thing is that when I am taking, so this is xi minus x bar, right? So what is xi here? 2. 2 minus, this is x1, okay? This is x2, x3, x4, x5. So what I will be doing, I will be subtracting all these values, right? So when I am subtracting 2 minus 4, I will be getting minus 2, right? Here next value is 4 minus 4, which is equal to 0. Next xi was 4, x bar is 4, so 4 minus 4, 0. Next value is 6 minus 4, right? xi was 6, x bar is 4, 6 minus 4, which is equal to 2. The next value is 8, 8 minus 4, which is equal to 4. Next is 10 minus 4, which is equal to 6. So what is the use of these two lines? That's what I'm going to tell. So here it is written like this, right? Mod of xi minus x bar. So I'll be writing mod here. The answer also will be having mod. The meaning of mod is whatever value I am inserting in the mod, my output will be always positive. Suppose I am writing mod minus 3, the answer is 3. If I am writing mod 2, it will always give positive only, so it will be 2. If I am writing mod minus 4, which is equal to 4. If it is mod 1, which is equal to 1. If I am writing positive, the answer will be positive. If I am writing negative inside the mod, the answer will be also positive. That is the meaning of this mod. Okay, I hope you understood. So what I will be doing, I will be, last they have mentioned what? Summation, right? Summation means what? We already discussed summation means adding all the terms, right? So I will be finding mod of all these terms. So mod 0 is 0, mod 2 is 2, mod 4 is 4, mod 6 is 6. So I will be adding all those terms. That is the meaning of what? Summation, right? So the simple step I will tell how can you do this. Suppose you are getting this question like this. You write this as xi. Xi is 2, 4, 6, 8, 10. This is your xi, right? So what I want to find in this equation, xi minus x bar, right? So I want to find what is xi minus x bar. So what I will be doing, I already know what is x bar, right? So what I will be doing here, 2 minus 4. This is 4 minus 4. This is 6 minus 4, 8 minus 4, 10 minus 4. You draw this table, so it will be very easy. So in the exam, you should definitely draw this table, okay? Your first column is xi. Next column is, in the equation we have xi minus x bar. So I am writing xi minus x bar, which is equal to, here this minus 2, 0, 2, 4 and 6, right? So next column is mod xi minus x bar. So mod is nothing but what? If I have a negative value, it will make it positive. So I have minus 2 here, it is 2. This is 0 only. Positive, always positive. 4, 6. So I got what? Xi minus mod xi minus x bar I got, right? Next I have what? Summation mod xi minus x bar is my equation. So what I will be doing, I will be adding all these terms. So I can write my AD is equal to 2 plus 0 plus 2 plus 4 plus 6 divided by n is nothing but what? Total number of observations, right? How many observations I have? 1, 2, 3, 4, 5. So divided by 5. So which is equal to 2 plus 0 is 2, 2 plus 2 is 4, 4 plus 4 is 8, 8 plus 6 is 14, right? So I'll be getting 14 by 5, which is nearly like 2 point something. Okay, so I hope you understood how to do this. So the first step, if you are getting a question like this, first you should write the first column as xi and write all the values which you got in the question. Next is, in your equation you have xi minus x bar, so you should write, your next column should be xi minus x bar, and the third column should be, we have mod of xi minus x bar here, so next column is mod of xi minus x bar. Okay, so summation means what? Adding up all the terms. So I added all the terms, divided by n is nothing but total number of observations. So I have 5 observations, so I wrote what? 5. Okay, so mod is nothing but what? If I am writing negative value or positive value inside the mod, my output will be what? Always positive. Okay, I hope you understood this. So I will explain what is the use of this average deviation. Okay, so we are having some the previous example, right? When we discuss measures of dispersion, that this one definition, we discussed 2 examples, right? Player 1 and player 2. So they were having some marks, right? So this guy was having, sorry, score, right? This guy was having score almost near to 50, right? Score all, sorry, almost near to 50 you are having, right? You are having from 10 to 90, right? 10 to 90 you are having the scores. So when we are calculating the average deviation, see in this particular data set all value was near to 50, right? So when we are calculating the average deviation, the average deviation for this will be very less. Average deviation for the player 1 will be very less. So for this guy it will be very high. Okay, this guy it will be very high. So based on this average deviation we can get to the conclusion that which player is good. Okay, so the meaning is that if average deviation is less, it is considered to be consistent. Okay, consistent. So if my average deviation is less means what? So if I am comparing player 1 and player 2, who is having very less average deviation, that player is having what? More. That player is considered to be more consistent. Okay, so that is the use of average deviation. I hope you understood this. So the similar thing only we are going to study next. That is nothing but variance. Nothing but variance. So we studied the equation of average deviation like this, no? Xi minus x bar divided by n. One mode was there. Instead of that mode, in the variance equation we are having the square of that. We wrote mode here, right? Instead of that we will be taking the square of this. Okay, now I will explain what do you mean by saying variance. The definition is very simple. Based on this equation only we can write the definition for that. If you study this equation, what is the meaning of the sum, right? So variance is nothing but this is sum, right? Sum of, this is square, right? Squared. So xi minus x bar, what did it gives actually? If I have 2 is my observation, my mean was 4, I'll be writing 2 minus 4, right? So that is nothing but what? Deviation, right? So the statement says that variance is sum of squared deviation from mean. Okay, sum of squared deviation from mean. Sum of squared, this is nothing but deviation, right? Deviation from what? Mean. All observation, how much deviation it has from the mean, that is what I am checking, right? So variance is sum of squared deviation from the mean divided by total number of observation. Okay, so variance is nothing but sum of squared deviation from the mean divided by total number of observations. Okay, and we are denoting this variance as denoted as okay, this is 9, right? I am writing 9 like this. Okay, this is called sigma. This is called what? Sigma. I am putting square here, so this is called what? Sigma square. How to pronounce this? This is sigma square. So my equation for finding the variance is sigma square is equal to sigma square is nothing but variance. Okay, so variance is equal to, or sigma square is equal to, summation xi minus x bar all square divided by n. Okay, so this is the way how we are finding the variance. Okay, so we'll see how to do one problem. We'll take the same problem 2, 4, 6, 8, 10. So this was my question. So I want to find the variance of this. So what I will be doing is first and foremost step is finding the mean. So I want this term, right? So first and foremost step is finding the mean. So we already found the mean as it is nothing but 20 divided by 5, which is equal to 4. We already found in the previous, when we are doing the average deviation, we found this, right? So based on the equation, my equation was sigma square is equal to summation xi minus x bar all square divided by n. So in that x bar we already found. So the same thing what we did in the average deviation, same step I will be following. First I will be writing xi and I will be writing the all values 2, 4, 6, 8, 10. Okay, I will be writing 2, 4, 6, 8, 10. So after writing 2, 4, 6, 8, 10, next step is writing what? Xi minus x bar. what is that? Xi minus x bar. In the average deviation also we follow the same, right? First we write xi, first we wrote xi, then xi minus x bar, then we wrote mod xi minus x bar, right? Here no mod is there. Instead of mod, what we have? Square, right? So my next column will be xi minus x bar all square. So first I will be finding what is xi minus x bar. So xi here is 2, right? So 2, so it is already there. Xi is 2, x bar is 4, so 2 minus 4. Here it is 4 minus 4, here it is xi is 6, and minus 4, 6 minus 4, 8 minus 4, 10 minus 4. So 2 minus 4 is minus 2, 0, 2, 6 minus 4 is 2, 8 minus 4 is 4, 10 minus 4 is 6. So I got this all values, right? So I want to find xi minus x bar all square. So I got xi minus x bar is this. So xi minus x bar all square is nothing but what? Minus 2 square, which is equal to what? What is the square root of minus 2? Which is equal to 4. Okay. When I am taking the square root of negative terms or positive terms, it will be always what? Positive. Okay. If it is 2 square, the answer is 4. If it is minus 2 square also, the answer is 4. Okay. Then x is 0 square. 0 square is nothing but 0. Next is 2 square, which is equal to 4. Here it is 4 square, which is equal to 16. This is 6 square, which is equal to 36. I hope you know how to find the square. Square is nothing but, if I am writing 6 square, the meaning of that is 6 into 6, which is equal to 36. Okay. Square means what? Multiplying the same term twice. Okay. So I wrote what is xi minus x bar all square. Now I want what? Summation, right? Summation means what? Adding all the terms. So adding all the xi minus x bar all square terms. So xi minus x bar all square term is here, right? 4, 0, 4, 1, 16, 36. So what I will be doing? My sigma square is equal to, I will be adding all these terms. 4 plus 0 plus 4 plus 16 plus 36 divided by, how many values I have? 5, right? 5. So I'll be adding this. So it is 20 and 40, 60, right? So it will be 60 by 5. So I got 60 by 5, which is equal to 12, right? So I got the variance as 12. For the variance also, the thing is same. We have player 1 and 2, right? Player 1, player 2. Player 1 was having the median 50, mean 50, here also mean 50. So the player which has less variance, is considered to be consistent. The same thing. Okay. In average deviation also, if the average deviation was less, that player is good. Here also, if the variance is low, which player is having very less variance, that player is what? Good, right? So here also we are talking about deviation. So the players who have very less deviation, they will be having what? They will be considered to be consistent. Okay, I hope you understood this. We'll do one more problem like this. Then we'll go to the next topic, that is standard deviation. That is very simple. The same thing, same step. Till here it is same. Only after this we should do one thing. That's it. Okay. So we'll do one more problem based on variance. Okay, so this is my question. Okay, so I want to find the variance of this. So first step is writing what is xi. 1, 3, 5, 9, 15. So before writing this xi, you should write the equation. The equation is nothing but what? Sigma square is equal to summation xi minus x bar all square divided by n. Okay, for writing this equation you have 1.5 marks. So kindly write this. Okay, if you forget the steps also, at least write this, you will be getting 1.5 marks. So after writing this equation, we should continue with this. So first I will be writing all the xi values. Next step is what? Writing xi minus x bar. Okay, so first step is finding what is, sorry for the inconvenience. First step is finding what is x bar. Okay, so we want to subtract, right? So first step is finding x bar. So what is x bar? 1 plus 3 plus 5 plus 9 plus 15 divided by 5, right? 2, 4, 5. Okay, So what will be the answer for this? 1 plus 3 is 4, 4 plus 4 9, 9 plus 9 18, 18 plus 15 is 33, right? So 33 by, so we'll consider this as 12, so it will be very easy for the calculation. Okay, let it be 12. Okay, so when we are calculating, it will be 8 20 30, so we'll be getting 30. Okay, change this time as 12. Okay, this is 12. So I got 30 by 5, which is equal to 6, right? So I got the mean as 6. So what I'll be doing, 1 minus 6. I got x bar as 6, xi is 1, so 1 minus 6, 3 minus 6, 5 minus 6, 9 minus 6, and 12 minus 6. So 1 minus 6 is nothing but what? Minus 5, right? This is 3 minus 6 is minus 3. Here it is minus 1. Here it is 9 minus 6 is 3. 12 minus 6 is 6. Okay, so I got xi minus x bar, right? So my next step is xi minus x bar all square. This is the last step. So xi minus x bar all square. So what I'll be doing, I'll be taking the squares of all these terms. So minus 5 square, which is equal to 25. I have already told that if you are taking the negative square also, positive square also, the answer will be positive. Okay, so minus 3 square is equal to 9, minus 1 square is equal to 1, 3 square is equal to 9, 6 square is equal to 36. Okay, so I got what? Xi minus x bar all square I got, right? So next step is what? Summation, right? So summation means what? Adding all those values. So it is nothing but sigma square is equal to 25 plus 9 plus 1 plus 9 plus 36 divided by n is nothing but what? N is nothing but 5, right? 1 2 3 4 5 observations I have, n is equal to 5, so which is equal to, so I'll be adding all this. So 35 plus 45 is 80, right? So I will be getting 80 by 5, which is equal to 80 divided by 5 is nothing but, it will be like, sorry, 80 divided by 5, right? Which is equal to 16. Okay, so I got the variance as 16. Okay, so I hope you understood how to do this. Okay, so you do one more problem as a homework, that is 2 8 10 20 13 15. Okay, so do one more, 2 1 3 3. Okay, 1 5 1 3. So next we will discuss what is standard deviation. Okay, so standard deviation. So this is very simple. If you study variance, it is very simple. Okay, so standard deviation, the equation is the same equation, xi minus x bar whole square divided by n. This was the variance equation, right? If I am putting a square root, this becomes standard deviation. Okay, if I am putting a square root, this becomes standard deviation. So this definition for standard deviation is also the same like variance. So standard deviation is so standard in variance we wrote what? Sum of squared deviation from the mean divided by total number of observation, right? Here we'll be writing this term also. First this square root of, only that one word is extra, square root of sum of squared deviation from the mean divided by total number of observation. The same definition, only one word is extra, that is square root of. Okay, square root of sum of squared deviation divided by square deviation from the mean divided by total number of observations. Okay, this is the way to find the standard deviation. This is the definition. So variance we denoted as sigma square, right? So here we will be denoting standard deviation as sigma. Okay, we'll be denoting this as sigma. So standard deviation is denoted as sigma. Okay, variance it was sigma square. It's very easy to understand. See, 2 square is equal to 4, right? So root of 2 square is equal to what? 2, right? Why? Because if I am taking the root of 4, I will be getting 2, right? So I hope you understood this. Or if you are not understanding, study this. If I am taking some square of something, and if I am taking the root of that square itself, I will be getting the same term. So root of 3 square is nothing but what? 3. Root of 5 square is nothing but what? 5. Okay, so root of, here it was root of, right? So I was having sigma square. I have taken the root of that. So nothing but it is sigma. If you are not understanding this, just study it is denoted as sigma. So it is equal to sigma is equal to root of summation xi minus x bar all square divided by n. Okay, so we'll see how can we find the sigma. Standard deviation. So we discussed, this is the variance problem. Okay, this is the variance problem. So 2, 4, 6, 8, 10 was my data. So first step is finding the mean, because my equation was root of summation, only one root is extra here, right? So first step is finding mean. Second step is writing, I got the mean as what? 4, right? Then I will be writing all the xi down. Next step is finding xi minus x bar, and I will be finding xi minus x bar all square. And my equation for standard deviation also it was same, right? Summation xi minus x bar all square divided by n, and root is there, right? So root of summation xi minus x bar all square divided by n was my equation. So first step is the same till last, it is same. Okay, so I will be writing xi minus x bar, then xi minus x bar all square I will be writing, then I will be adding up all the terms, nothing but summation I will be adding, dividing it by n. All these things will be done. At last we will be getting 12, right? So 12 is nothing but without root, right? So the answer for standard deviation is nothing but sigma is equal to root 12. This is nothing but your answer for standard deviation. So while writing the notes for standard deviation, write the same question and do the same step, and at last write sigma is equal to root 12, because standard deviation is what? Root of this particular term, right? So I will be writing root of this answer. So here also it is same. Okay, so sigma square, I got the sigma square as what? 16, right? So therefore my sigma is equal to what? My sigma will be equal to, sigma is nothing but standard deviation is equal to what? Root of 16. Root 16 is nothing but 4. Okay, so it will be 4. Okay, I hope you understood this. The all steps are same. At last I will be writing the root of the final answer. Okay, and the thing is that if this question was given and it is asked to find the standard deviation only, then don't write this equation. Instead of that, you should write sigma is equal to root of summation xi minus x bar all square divided by n. So this equation you should write. Don't write this and prove till here and then write sigma. Instead of that, you should write this equation. Okay, done. I hope you understood this. Now we have two more topics. One is grouped standard deviation and grouped variance. So we have seen this kind of data, right? 0 to 10, 10 to 20. For this also you should study how to find the variance and how to find the standard deviation. Okay, that is also very simple. The same equation, one extra term is there. Okay, the case of standard deviation also, the interpretation is same. The same example of player 1 and player 2, if I am taking player 1, player 2, the player which is having very less standard deviation, it is considered to be consistent. Okay, it is considered to be consistent. The player is considered to be consistent. Okay, so for average deviation, variance and standard deviation, the interpretation is same. Those who are having very less value, they are considered to be consistent. Okay.